You are currently the only person in this conference.
Good evening, students. I'm just waiting for the other students to join. Okay. Okay, students, I'll start the session. See, students, slabs. I want to start the slabs. Sir, in slabs, we have two conditions. One is one-way slab, and other one we have is two-way slab. Okay, slabs are of two kinds. One is one-way slab, and other one is two-way slab. Okay, one is one-way slab, another one is what, sir? Two-way slab. Now, what is one-way slab and what is two-way slab? See, student, here. Slab which is spanning in one direction. अगर one direction में slab which is spanning in one direction. Slab which is spanning in one direction is known as slab which is spanning in one direction is known as one-way slab. Slab spanning in two-way slab means slab spanning in both directions. Two-way slab means slab spanning in both directions. Slab which is spanning in both the direction. Now see, students, actually we have a concept called, sir, is it clear? One-way slab means slab spanning in one direction, slab spanning in both the directions. See, suppose if it is a one-way slab, it will be something of this kind. It is a means it will be spanning only in one direction like this. In two-way slab means it will be almost spanning in both the directions. So for this, we will study about a ratio called aspect ratio. My dear students, we study about the ratio aspect ratio. What is aspect ratio? Suppose, see, students, if I consider this as Ly and if I consider this as Lx, okay. Now see, students, Ly by Lx greater than 2, then it is one-way slab. Now see students, Ly by Lx greater than means this length will be very much more compared to this length. So that is the reason it will be greater than 2. But here both are almost same length. So Ly by Lx less than or equal to 2, then it is a two-way slab. Clear, my dear student? This can be an objective question. In your college, sorry, in your exam, this can be a absolutely important question. So slabs are of two kinds. One is one-way slab, another one is two-way slab. So slab spanning in one direction is called as one-way, and slab spanning in both the direction, it is called two-way slab. When Ly by Lx ratio greater than 2, then it is called one-way slab. Ly by Lx less than or equal to 2, or you can write not greater than 2, then it is called two-way slab. Clear, my dear students? Okay. Now see students, see we have span. See here we have a concept called span to effective depth. Span upon effective depth ratio. We have to study this span upon effective depth ratio because we estimate the depth, effective depth of the slab based on this ratio. But up to span up to 10-meter length only. Up to 10-meter length, span by effective depth ratio is equal to 7. This value is 7 for cantilever beam. It is equal to 7 for cantilever beam. And this span by effective depth is equal to 20. They can ask you this question directly, student. For simply supported beam, and span by effective depth is equal to 26 in case of continuous beams. So this can also be an objective question, students. So the span by effective depth is 7 in case of cantilever, 20 in case of simply supported beam, and 26 in case of continuous beam. Suppose if you talk about up to 3.5 meter, if you talk about up to 3.5 meter, if you talk about up to 3.5 meter, span upon up to 3.5 meter, span upon effective depth up to 3.5 meter, span upon effective depth is given by the formula 35, or that is equal to 40. This 35 is for simply supported beam. सर सी स्पैन कम है तो डेप्थ भी कम, इसलिए ये वैल्यू ज्यादा है. आपको समझ में आता है सर? स्पैन कम है तो उनका वैल्यू ज्यादा है, तो स्पैन बाय 35 वैल्यू कम है कंपेयर टू स्पैन बाय 20. सो इसलिए स्पैन कम, इफेक्टिव डेप्थ कम है. आर यू गेटिंग माय डियर स्टूडेंट्स? एंड फॉर कंटिन्यूअस बीम्स स्पैन बाय इफेक्टिव डेप्थ इज 40. समझ में आता? सर इफ द स्पैन ज्यादा है तो इफेक्टिव डेप्थ भी ज्यादा है, वैल्यू भी कम है. स्पैन कम है तो इफेक्टिव डेप्थ भी कम है, उसमें के पास वैल्यू ज्यादा है. ऐसा लॉजिकली रिमेंबर कर दो. ओके. नाउ सी स्टूडेंट, आई टोल्ड यू slab footing is nothing but an inverted slab. So here if they ask you the cover provided, whatever the cover provided for slab, the cover provided for slab is how much, students? It is equal to 20 mm. The cover provided for slab is how much? It is equal to 20 mm. Next, see students, the minimum percentage of reinforcement, the minimum percentage of tensile reinforcement, the minimum percentage of tensile reinforcement is given as here 0.12 percentile of gross area in case of HYSD bars. And I have told you these values even in footing, because footing is nothing but an inverted slab, or 0.15 percentile of gross area in case of Fe 250, or you can say mild steel. Fe 250 or mild steel. Fe 250 or mild. 0.15% of gross area in case of FE 250 or mild steel. Yes, शाहिद मैं समझ में नहीं आता. First slide, second slide, third slide. ठीक है इमरान. So when I talk about the spacing here, इधर spacing consider कर दिया तो slab में क्या होता है ना, spacing is equal to for main reinforcement. If you talk about main reinforcement, spacing can be minimum reinforcement for main reinforcement is 3D or 300 mm or 300 mm. Main reinforcement is 3D or 300 mm, whichever is lesser. If you talk about secondary reinforcement, sir, you know what is main reinforcement and secondary reinforcement, right? The main reinforcement will be here and the secondary reinforcement will be somewhere here. For secondary reinforcement, the secondary reinforcement cannot be spacing. When you talk about secondary reinforcement, spacing can be 5D or 450 mm, whichever is lesser. Now, my dear students, they can ask you, suppose in a slab, the thickness of the slab, if you assume as some T, sir, see the maximum dia of bar used in the slab, maximum dia of bar used in slab, the maximum dia of bar used in slab cannot be more than thickness upon 8. This is an important objective question, students. Kindly repeat. क्या है sir? Imran, which one you want me to repeat it? Sir, इधर see the minimum percentage of tensile reinforcement, sir. Actually, this HYSD bar का strength ज्यादा है, इसलिए वो कम है. FE 250 का strength कम है, इसलिए वो ज्यादा है. Spacing of main reinforcement means if you provide in a slab, central band, see, this will be L by 8 and this will be L by 8. At central band, you will be providing the main reinforcement. The main reinforcement spacing, this you have to follow. If you will provide a secondary reinforcement for shear or torsion, that case you have to follow this spacing. From first slide. Sir, see, in slabs, there are two things. One is one-way slab and two-way slab. Slab which is spanning in one direction is known as one-way slab. Slab spanning in both the directions, it is two-way slab. Sir, we have a concept called aspect ratio. वो aspect ratio का दो का ज्यादा है तो वो टाइप में one way slab है. Aspect ratio दो का कम है तो sir, this slab is spanning in both the directions. So this ratio will be less. If this ratio is more than 2 means it is spanning in one direction. So that is how the one way slab and two way slab defines. Now, sir, see, अगर span ज्यादा है तो और effective depth भी ज्यादा है. So in case of cantilever, span the effective depth is 7, simply supported 20 and 26. These values are these values are up to span up to 10 meter. If the span is up to 3.5 meter, उसमें value भी कम है because span कम है, effective depth value भी कम है, इसलिए इधर value ज्यादा है. वो simply supported और continuous का. Next, this is how the slab cover requirement. Okay. Next. Sir, see. What is the advantage of two-way slab? If anyone asks you, what is the advantage of two-way slab is, The advantage of two-way slab. Advantage of two-way slab is the load will be transferred. Load will be transferred. What's that? Load will be transferred to all the four supports. Load will be transferred to all the four supports. Okay. Sorry. Load will be transferred to all the four supports. Load will be transferred to all the four supports. Load will be transferred to all the four supports. And you can say that as the load is transferred to all the four supports, suppose if you see the column like this, if you see, the load will be transferred to all the four supports. So the bending moment and the deflection will be small. The advantage of two-way slab is the bending moment and deflection will be small. ठीक है स्टूडेंट्स, सबको समझ में आता? If you talk about your slab, sir, then it is a two-way slab. Suppose if you are in a building, on top of your bedroom or anything, a hall, you will find two-way slab. Then where do you find one-way slab? If you talk about sunshades or lintels, they are all one-way slab. The lintels are the best examples of one-way slab. Okay. Now see sunshades. Suppose if you want to put, this is a portico, you'll have one span which is like this lintel or those will be one-way slab. Now see students, according to the IS code, actually IS code has given, okay, different moments. Suppose for restrained means it is null. It is not allowed to move. Restrained means. So for restrained slab, restrained means both ends. Restrained means both ends are something like fixed, or it can see. Restrained means both ends are fixed. It is allowed not to move. Suppose in case of restrained slabs, or the corners are prevented from lifting, means they are allowed not to move. If the corners are prevented from lifting, or the corners are prevented from lifting, means these are the corners. These corners are prevented from lifting, means no torsion, you can say indirectly. If the corners are prevented from lifting, in this case, moment in x direction will be equal to alpha x into, or you can write maximum bending moments. Maximum bending moment per unit width. Maximum bending moment per unit. Maximum bending moment per unit width will be equal to alpha x into WLX square, and my is equal to alpha y into WLY square. What's that? Mx is equal to alpha x into WLX square, and my is equal to alpha y into WLY square. So this is the moments. Okay. Now you'll ask me what are alpha x and alpha y. W is the load per unit area. Okay. Alpha x and alpha y are the coefficients based on boundary conditions. If the slab is continuous or discontinuous, or it is prevented from yielding, or restrained or unrestrained. So alpha x are the coefficients. Alpha x and alpha y are the coefficients which depend. Alpha x and alpha y depends on boundary condition. Sir, see, I'll tell you one thing. Suppose you have a window here. Okay, on top of a window you'll have a lintel kind of thing. Sir, this length can be very much. Here the span width is very small, length compared to length. So this is one-way slab. Suppose if you are in a building, if you see all the floor, entire, this is a two-way slab because the span is moving in this direction and it is also moving in that direction. Shahid sir, are you clear, sir?
सर कॉलम वन वे में भी 4 ही तो होंगे सर, उसके ऊपर अगर लेंथ ज्यादा होगी विड्थ कम होगी।
सर सिंपल सर, सर वो लेंथ ए भी ज्यादा है, ए भी कम है इधर सर, ऐसा भी ए भी वन वे स्लैब है, ए भी वन वे स्लैब है, वो ए वैल्यू इधर से कम है, ए वैल्यू इधर का कम है, दोनों में ऐसा होता है। ठीक है सर।
ओके सर।
Lintels, sunshades are the best examples. Sir, see, actually this is the basic concept which you require. I will give you some problem, means some questions. Suppose problem here is they have given a reinforced concrete slab, an RCC slab of 75 mm thick. An RCC slab of 75 mm thick. Maximum dia of bar is RCC slab 75 mm thick. Maximum dia of bar is RCC slab is 75 mm thick. Maximum dia of bar is A 12 mm, B 10 mm, C 8 mm, and D 6 mm dia. D is 6 mm. Mohammad Rashid, sir, in a supports everything, it is continuous. It will become, sir, see, it will become, Mohammad Rashid, it will become two-way slab only. Sir, see, Mohammad Rashid, what I want to tell you is, in any slab, if suppose this support to this support, this length is more compared to this support, then it is one-way slab, sir. See, the ratio, that is the reason I told you, Ma, this ratio, please keep in mind. If you keep the ratio in mind, your doubts will come across. Now, see, sir. See, what is he's asking? 75 by 8. This is the mistake you will do. So, it will be around 9.30 means 9.375, I think. Sir, most of the people you told it is 10 mm. 10 mm is absolutely wrong because dia of bar cannot be more than 9.37. So it should be, it can be 6 or 8. Out of 6 and 8, which is maximum? 8. Sir, Momin Rashid, this is the mistake usually people will do. अगर वैल्यू 9 पॉइंट दो तो उनका ज्यादा 10 दिया तो उनका कंडीशन एक्सेप्ट नहीं कर दिया, इसलिए उसमें कम है. Are you following everyone, my dear students? That is the reason I have given this problem.
रिपीट करना सर.
Repeat करना. Sir, अगर see, what is the condition, sir? Maximum dia of bar cannot be more than thickness by 8. उधर thickness कितना है सर? 75 by 8. So उनका वैल्यू it should not be greater than 9.375. अगर 10 किया तो उनका 9.375 का ज्यादा रहता ना. इसलिए it will be equal to how much, sir?
तो जो स्लैब है इसमें हम जो डाया ऑफ बार है वो मिनिमम हम जो है इसमें कितनी प्रोवाइड करते हैं सर? मिनिमम डाया कितना प्रोवाइड करते हैं?
8 mm. Usually minimum dia of bar is 8 mm.
ओके सर.
सर अगर स्लैब थिकनेस वेरी कर दिया तो उसमें ऐसा कर दे, इसलिए मैं बोल दिया.
और मैक्सिमम कितनी रहेगी सर?
Now, usually they provide maximum 16 mm. Usually, not more. So depending upon the building, sir. It depends upon the building also.
ओके सर.
Now see, for shorter, I am giving you these questions also. For the shorter story height, cheaper from work, and better lighting facilities, better lighting facilities, better lighting, better lighting facilities, better lighting facilities. What is the recommended? What is the recommended? What is the recommended slab floor? What is the recommended slab floor? Can anyone tell me what is the answer? Sir, see, for shorter story height, cheaper from work, and for better lighting facilities, we will go with flat slabs. Sir, actually in slabs also we will have yielding theorem. Suppose based on the cracks also. So based on the cracks also, the slabs will be designed. Actually, if you, that is not required actually. In some cases they will be designing in this way and all. Some cases in this way. But that is not required for you, Amma, in the complete exam. Okay. Next question is, give you another question, sir. In two-way restrained slab, torsion steel is provided. I'll give you 1 minute of time. Can anyone tell me? In two-way restrained slab, torsion steel is provided at. In two-way restrained slab, torsion steel is provided at. Sir, when there is a two-way restrained slab, torsion steel will be provided at top and as well as bottom also. It will be provided where, sir? Top and bottom also. I told you already, sir. If you see the thing, students, if you see, I have shown you the slab. If it is like main bar, and if you see here, I told you like mesh. That is the reason they are provided top and bottom. Do you remember that, students? Are you following, Amma? Next, sir, are you following, students? इसका समझ में आता? Sir, मैं okay. Next, in two-way slab, lifting of corners in two-way slab, lifting of corners in two-way slab, lifting of corners occur due to, in two-way slabs, lifting of corners occur due to. Please tell me this, students. Sir, lifting occurs due to, I told you already this also. In a two-way slab, lifting will be occurring due to what, sir? Due to torsion. Lifting will be occurring due to torsion. Agree, students? Very good, Omar. Very good. Next. I'll give you another question, Amma. The question here is a simply supported slab. You can write here a simply supported. Huh? A simply supported slab. A simply supported slab of 10 meter effective depth of 10 meter. Simply supported slab of 10 meter effective span of 10 meter effective span. The minimum effective depth, the minimum effective depth, the minimum effective depth to satisfy the vertical deflection is. To satisfy the vertical deflection is. Can anyone tell me, students? Now see, minimum effective depth is telling. So effective length by span, you know, span by effective depth up to 10 meter is telling is equal to what, sir? I told you for simply supported beam it is equal to 20. So you can write here 10 meter by 20, that is equal to how much, Amma? That is equal to 0.5 meter, or that is equal to how much, sir? 50 centimeter, or that is equal to 500 mm. समझ में आता सर? Is this clear? Next. One second, students. So here you are clear about the minimum specifications and all, right, students? So we have studied, sir, actually span by effective depth ratio, one-way slab, two-way slab, cover, all these are the questions. Usually we can expect in the objective point of view, students. Okay. Now, this is also another important thing. See, students, if you consider in a slab for a cantilever beam, reinforcement will be provided at top. Okay. Reinforcement is provided at top. This is important. If you talk about simply supported beam, reinforcement will be provided at bottom. Reinforcement will be provided at bottom. These things also can be a question, sir. Okay. Okay, fine, student. Is it fine, students? Is the slabs clear for you? So let us move on to the next topic, that is the bond. Sir, see, why you want to talk about, sir, most of the people will think that, sir, in pre-stressor concrete or anything, bond is the main factor. You can say in RCC, bond is the main factor for transfer of stresses from steel to the concrete. What, sir? You can say bond is the main factor.
इसी चैप्टर में सर ये
Sir,
इसी चैप्टर में
Rohit, what is your doubt?
मैंने कहा सर चैप्टर सेम ही है
No, different chapter, sir. Sir, it is not about chapter or anything. You can go continuation, okay?
Or sometimes we bend the steel in the on the sides of the slab. So why do we do that?
Mohammed Rashid, I didn't get you. Can you repeat that point again? Sometimes.
Yes, sometimes we bend the reinforcement. Bend.
Yeah. That I will be covering here, Mohammed Rashid. In bond, I will be covering. Like if you
Okay.
put 180 degrees, 135 degrees, like that, right?
Yes, sir. Yes, sir.
Now that what I want to cover here. Good question.
Okay.
Now see, what is a bond is? Bond is the main factor of stresses from steel to concrete. Bond is the main factor of transfer of stresses from steel to bond is the main factor for transfer of stresses from steel to. Now see here, students, what I would like to tell you is in bond actually how this is bond is developed. Sir, they can also give you bond is nothing but if you talk about bond stress, actually we should talk about the bond stress. Bond stress is nothing but for your information, it is nothing but the shear stress, sir. It is the shear stress developed between bar and concrete. The stress developed between shear stress developed between bar and concrete is nothing but the shear stress developed between bar and concrete is known as bond stress. Is known as what, sir? Bond stress. What are the factors which can affect the bond stress is one is the frictional resistance, or you can say mechanical resistance. That is what your friend has told, Mohammed Rashid. Like whenever there is a bending or tries to hold hook like or pure adhesion. These are all the factors. Pure adhesion means it acts like a gum, sticky nature. Adhesion means sticky. Chewing gum. So bond stress is the factors. What are the factors affecting bond stress? Factors affecting bond stress is friction, and next one is mechanical resistance, and next one is the pure adhesion. Okay, in types of bonds also, we also talk about the flexural bond. In types of bond, we also talk about flexural bond. Sir, flexure means what, my dear students? What is flexure? For your information, flexure is nothing but flexure का meaning क्या है, sir? Bending. Flexural bond is nothing but what? Bending. So flexural bond is developed in the case of when the length of the bar is more. When the length of bar, usually when we take length of bar, the length of the bar, or you can say flexural stress developed along the length of the bar. It will develop, the flexural bond will develop along the length of the bar to make, or sir, actually the intention of bond is to make steel and concrete act together. To make steel and concrete act together. So along the length, whatever the stress is developed, then it is called flexural bond. So along the length of the bar, if you see here, when you talk about here, when you consider along the length of the bar, to make the steel and concrete act together, then that is called a flexural bond. That is called what's flexural bond. Similarly, what they can ask you is, sir, please repeat factors. Okay. Sir, see, bond stress का factors क्या है, sir? Friction, sir. Sir, you see, suppose friction means if there is a plain bar and concrete is there is slippage. Instead of that, if the bar is like threaded, there will be a friction between concrete and steel. That is pure, that is called friction, sir. A rough surface will have more friction. Okay, that's what. Pure adhesion means a gummy like thing, sir. Gum, chewing gum and everything. That is, If it is having sticky nature, bond is also more. Mechanical means, suppose, sir, see, you have a hanger, you will put your clothes on front of this. But if you put like this hanger, it will tries to hold the concrete and steel together. So those are the factors. Mohammed Dawood, is it clear, sir? So bond stress can be achieved by three things: friction, mechanical, and pure radiation. Okay. Now see, sir, very, very important concept, that is development length. What, sir? That is development length. What? Next one. Next one we have is the development length. So what is development length is, sir, see, suppose if you have a bar here, okay, they will talk about the development length like this. Okay. Now see, sir, what actually is development length is the reinforcement bar. The reinforcement bar must extend. The reinforcement bar must extend in the concrete. The reinforcement bar must extend in the concrete sufficiently. The reinforcement bar must extend in concrete sufficiently. Must extend in the bar sufficiently. The reinforcement bar must extend in the concrete sufficiently so that it can develop. So that it can develop. So that it can develop. So that it can develop required stresses. So that it can develop what's required. So that it can develop required stresses. Now see, students, the extended length of the bar, the extended length of bar, the extended length of the bar required to transmit the extended length of the bar. This is the extended length of the bar required to transmit the bar force to required to transmit the bar force to concrete is nothing but what, sir? It is nothing but what? Development length. And development length is given by the formula phi into sigma s upon 4 tau bd. Yes or no? Yes or no, students? Where phi is the dia of bar, where phi is the dia of bar, and sigma s is nothing but yield stress. That is also called as, you can write here, or you can write as 0.87. So you can write phi into 0.87 Fy by 4 tau bd. Sir, see how this formula also came. I'll tell you, Amma, just for your information. Sir, see, there is a bond stress here. So bond stress is tau bd, and the pi dl. This bond stress is what, sir? It is acting around pi into diameter into this length is how much, sir? Development length, LD. This is what? Force. And this force should be equal to the other force in the steel, that is 0.87 Fy, area of the bar, that is pi by 4 d square. So here pi cancel. D will be cancelled. So if you see here, LD is equal to 0.87 Fy into D upon 4 tau bd. Sir, are you clear how this formula came? Is this clear, students? Sir, I have equated bond stress means the stress which is developed due to the concrete. that is equal to the tension force, that is 0.87 F by AST. AST is nothing but pi by 4 d square. So that's all. Okay, fine students. What about remaining students? Azit, Imran, Mohammed, Momin Rashid, Neena Rashid, everyone. Are you clear, Amma? Asima, Ayub. Sir, can you please respond, students? Is this clear for everyone? Rohit, Shahin Shah, Simran Nazir, Saurav, Tanveer, Umar, Wakar, Yatim. I hope you are clear. Sir,
सर
development
जो
length is very. Rohit, come again.
सर जो कंक्रीट के अंदर है इसमें जो स्ट्रेसेस होंगे इसको हम डेवलपमेंट लेंथ बोलेंगे, कितनी हमने प्रोवाइड की हुई है।
ऐसा नहीं है सर। सर अगर एक रॉड है, वो रॉड कंक्रीट का इतना दूर इंसर्ट कर दिया तो उधर स्ट्रेसेस डेवलप, आपका कितना दूर वो बार का अंदर रखने के लिए कितना लेंथ है, वो भी डेवलपमेंट लेंथ है। सर अगर रॉड ऊपर है तो उनका बॉन्ड अच्छा नहीं है, वो इतना दूर अंदर है तो उतना बॉन्ड अच्छा है। सो वो दूर कितना है, वो दूर कितना है तो वो बोले था डेवलपमेंट लेंथ। सर व्हाट
ओके
हैपेंस साइड से इज सर सी, sir, actually there is a bar which is introduced into the concrete, Amma. How much bar, how much length you have to extend this bar into the concrete is nothing but development length. Okay, so here what is the condition is the stresses here is shear force. I told you bond stress is nothing but shear stress. So tau bd, and this is acting along the surface. So surface means perimeter into length, surface area, 2 pi r into length. This is equal to tensile force of steel 0.87 Fy into pi by 4 d square. अगर दोनों का इक्वेट कर दिया तो उनके पास क्या होता है, डेवलपमेंट लेंथ फार्मूला विल बी इक्वल टू, और डेवलपमेंट लेंथ इज इक्वल टू 0.87 Fy dia of the bar upon 4 tau bd, where tau bd is the bond stress, where tau bd is the bond stress. सबको समझ में आता है सर? शाहिद शाह, क्लियर? Students, please take 5 minutes. I'll be back in 5 minutes. Okay, please stay. Don't go, Mama. We have different important topics. Welcome back, students. Now, see, students, actually, we have very important thing here. The thing is that to see, students, we also have to discuss about the important concept now. Sir, bond. Actually, bond, this question can be increased, sir. Suppose what is tau BD, students? Tau BD is called as what, sir? Bond stress. See, students, इधर tau BD क्या है? Tau BD is nothing but bond stress. Tau BD is nothing but what, sir? Bond stress. Tau BD is nothing but what, sir? Bond stress. Now, see, students, this is important. Bond stress will be increased by 60% in case of tar bars. Sir, do you know what is a tar bar? Like we say, tar bar means mechanically treated bar, or you can say tar bar means a bar which is having threads. Now see, it is suppose in this case you have to take 1.6 tau BD. In this case, you have to take 1.6 tau BD. Sir, see, tau BD depends upon grade of concrete. Suppose depends. Tau BD depends upon what, sir? Grade of concrete. So if you take different grade of concrete, how do you know these values? Means from code only. Suppose if the grade of concrete is M15, or if you say M20, or M25, or if I say M30, I'm giving. So in this case, tau BD is equal to what, sir? 1, 1.2, 1.4, and 1.5. Okay. This is the tau BD. Now see, students, in this case, suppose they can ask you for M20 concrete, for tar bar, what is the thing means? 1.6 into 1.2, that will be equal to 1.92. Now see, students, in case of compression, are you following, students? James Bond. No James Bond, Mohammed Rashid. James Bond is very strong in hands. This bond should be very strong in bar. Okay. Now see, here in case of compression, if we talk about in case of compression, okay, this tau BD will be further increased by 20%. Sir, actually further increased by 25%. Tau BD further increased by 25% in case of tar. That means what it will happen here? Here in this case, tau BD will be equal to 1.6 tau BD. This is further increased by another 1.25. So in case of compression, it will be equal to 2 times tau BD. Clear, students? In case of compression, tar will be increased by 25%. Now you will ask me, sir, why you have told 1.25? Suppose tau BD is given as 1.2 in tar case, then you have to take 1.25 into 1.2. That will be equal to how much, sir? 1.5. But if tau BD is given initially is 1.2, in case of compression, tau BD will be equal to 2 into 1.2. In that case, it will be 2.4. So that is the reason in tar it is increased by 1.25. If it is initial, then it is increased by twice. Are you getting, my dear students? Okay.
सर जैसे अगर कंप्रेशन के लिए पूछा होगा तो उसके लिए जैसे 25% होती है.
Okay.
तो हमने जैसे
25% क्या होते हैं उसमें, टॉर के 25% का ज्यादा है, टॉर से 25% का ज्यादा, इनिशियल बॉन्ड स्ट्रेस के डबल हो गया। समझ में आता रोहित?
सर जो हमारे पास 60% हमने लिया सर टोर बार के लिए हमने, और
सर
नीचे सर जैसे
एक्चुअली सर, अगर टाउ बॉडी, दिस इज बॉन्ड स्ट्रेस, if bond stress is 1.2, in case of tor bar it will be equal to 1.2 into 1.6, that will be equal to 1.92.
ये सर
Suppose tau bd of tor is how much? They are given as 1.5. In this case, what will be tau bd of compression means 1.5 into 1.25. That will be equal to how much, sir? 1.875. Yeah?
ये सर
So what? See, student, you have to understand this simple mathematics. Some there, nothing. Next thing
कंप्रेशन
what?
में डबल हो जाएगा।
Compression में double हो गया. Yes. Sir, if you comparison is required there. No, see, sir. Next, we have to talk about the anchorage length. Next, we have to talk about anchorage length. What is anchorage length is? That's what you told, no, sir? Sir, see, anchorage length means what is the length you have bent, okay? Or what is the length you have bent here in different angles. So what is anchorage means? Suppose see in a hanger, to hold something is nothing but anchorage, sir. You can say it is a bend of anchorage length means it is a bend of longitudinal reinforcement, a bend of longitudinal reinforcement. The bend of longitudinal reinforcement which is equivalent to length of straight bar, equivalent to length of straight bar. Suppose see students, the bend of longitudinal reinforcement equivalent to length of straight bar. So see here, suppose angle of bending is 45 degree, 90 degree, 135 degree. This is what is used. Mohammed Rashid, you are the one or someone has asked me this doubt here? Asmullah, I think someone has doubt. Sir, who has asked this doubt? Someone. Sir, if the bend is 45-90, anchorage value. Sir, anchorage value is something like development length also. Anchorage value is something like this. In this case, it will be equal to 4 times 5. It will be equal to 8 times 5. And it will be equal to 12 times 5. And this will be equal to 16 times 5. This is the anchor, dia of bar. What is 5 means? 5 is nothing but dia of bar. Okay, sir? Next. The next one, what I would like to tell you is check for development length. What, sir? Check for development length. The development length should be less than or equal to m by v plus L naught. Remember, students, development length you cannot provide whatever you want. It should be less than or equal to m by v plus L naught. Immediately you will ask me what is m by v. M1 is the moment of resistance of steel bars. M1 is the moment of resistance of steel bars. M1 is the moment of resistance of steel bars. M1 is the moment of resistance of steel bars. And V is the vertical shear force at the section. V is the vertical shear force at the section. V is the vertical shear force at section. L naught is the equivalent bend length of a hook. Equivalent bend length of a hook. Or usually it will be equivalent bend. How much bend is bend length of hook? Equivalent bend length of hook. Usually it will be equal to 12 times 5. Nena Rashid, what actually happens, Amma? See, that is similarly the anchorage values I had is asked. Nena Rashid, every time it is 45 degrees, then it is equal to 45. Yes. That is the what core says. Code. But see, sir, actually the development length will be less than or equal to 1.3 upon m by v plus L naught if the ends of reinforcements are subjected to compression. If the ends of reactions or ends of reinforcement are subjected to compression, they can ask you this question, Amma. If the ends are subjected to compression, how much value of moment is increased? 1.3 means how much, sir? It is increased by 30%. They will ask you directly this question. In case when the ends are subjected to compression, what will happen to check the development length? In that case, it will be equal to what, sir? It will be increased by 30%. Clear, students? आपको समझ में आता? और डेवलपमेंट लेंथ का चेक, सर. Next.
Sir, anchorage length is given at the end of the slab, no, sir?
What, Amma?
So anchorage length
Yes.
when we bind it.
Yes.
So, but sometimes the steel is bended before the end section.
No. See, Mohammed Rashid, what I want to tell you is not at the ends or something. How much the bend is there, that value will be calculating from here based on the angle of bend. Suppose it is 45 means it is like this. If it is 90 degrees means like this. If it is 130, see. Suppose if you see the angle, Amma, this is 45 degrees, this is 90 degrees, and this is 135. And if you say it is 180 means it will be completely. So based on the bend, we'll do this. Mohammed Rashid, can you is it clear for you?
कभी कभी स्लैब जो होती है ना, सर, जैसे लेंथ और लेटरली और लॉन्गिट्यूडली सीधा स्टील डालते हैं हम. बट कभी कभी मैंने देखा है सर, जब लास्ट फॉर एग्जांपल 10 फीट का है स्लैब, एग्जांपल 10 फीट का है, जो
Okay.
8 फीट के बाद
Sir,
वो
that
बीच में.
is, see, that you will come across expansive joints. Actually, that is different. I got it now. Sir, say in that case, you will be doing splicing. Means you will be, means how you will be joining, how you will be bending and all. That is a peculiar case. Depending on, these are at the ends only. Those are the peculiar case which comes under site, sir. We don't have specific values as per the code. Now I got it, what you are trying to say.
Yes, sir. Okay, sir.
Yes. It can be lap joint also. Now see, sir. That's what I want to tell you here. Now see, students. See, this is important one. Bar, see, splicing of bars. Do you know what is splicing of bars? Anyone? समझ में ना? What is splicing of bars? Joining two bars is nothing but splicing of bars. Splicing of bars should be avoided. These are important number. Splicing of bars. Splicing means joining. Splicing of bars should be avoided where bending moment is 50%. Where bending moment is 50% of moment of resistance of the section. MOR means you know, right? You have to avoid splicing of bars where bending moment is 50%. Next. And not more than 50% of the bars should be spliced. You cannot splice all the bars, not more than 50% of the bars should be spliced. Whatever the bars you are splicing, they should be less than 50%. Next. Are you following, students? Splicing means joining. Splicing means nothing but joining. Splicing of bars should be avoided where bending moment is 50% and it should not be more than 50%. And this is important now. Bars of dia, 36 mm, bars of dia, 36 mm, bars of dia, 36 mm should not be spliced. They should not be spliced. Then what should we do? Can anyone tell me? Bars of dia 36 mm should not be spliced. Then what we have to do? Sir? They should be welded. What, sir? Bars of dia, they should be very good, Mohammed Dawood. They should be. Bars of dia 36 mm should not be spliced. They should be welded. Okay. Suppose, see, student, I told you, no, if there is a bar or anything, this we call it as lap length actually. Sir, see, students, lap length of bars. Okay. In different conditions, we have to study. First, in case of bending tension, lap length should not be less than LD. What is LD, sir? LD or 35. LD means development length. And also direct tension. Lap length in case of direct tension should not be less than 2 times LD or 30 times 5. So what we have to see, in case of bending tension, it should not be less than LD or 35, or in case of direct tension, it cannot be 2 LD or 35, or in case of compression, it should not be less than LD or 24/5. So in case of compression, it should not be less than LD or 24/5. It should not be less than LD or 35, or it should not be less than 2 LD or 35. This is in case of direct tension. This is in case of bending tension. And this is in case of compression. Clear, students? Sir, you have to remember all these things. Now see, sir. Next, development length. See, sir. Development length. If you consider 2 bars, development length of 2 bars. If you bundle 2 bars, in case of bundling of 2 bars, the development length LD will be increased. Upward arrow means 10%. In case of 3 bars, 20% increase. What 20% increase? Development length. In case of 4 bars, it will be increased 30%. Sir, why actually the development length is increased by 30% and log? Means if you see 4 bars are bundled here, this contact area will not be contact with the concrete. That is the reason in this case development length is increased by these values. Are you getting me, sir? As the contact surface area will be reduction, that is the reason development length will be increased. Clear, my dear students? Any doubts, sir? Any doubts in the bonded connection? Sorry, any doubts in the bond topic? Can you tell me?
डायग्राम में रिपीट करना सर, ये डायग्राम में कैसे सर?
Sir, ऐसा now see, suppose if you have a steel bar, you will have a concrete here. If you have another steel bar, you will have a concrete here. But if you see two steel bars bundled like this, now they are having the contact area here and here. They will not have contact area here, so it is missing, right? Suppose if you see in 4, the same case will happen. This entire contact area will be missing. That is the reason. Sir, you have to imagine that simply. Sir, सबको clear है? Next, last topic for RCC. Okay, last topic, and I'm just giving. Sir, nowadays no one is using this method. Actually, still I'm telling you. Sir, working stress method. Sir, see, in working stress method, I would like to tell you very, very important things only, because we are not using this method in practical. Sir, see, here in working stress method, strain varies linearly, and also stress also varies linearly. This is the important thing you have to know. Stress and strain varies linearly. Okay, so here if you see in pre-stressor concrete, whatever we have discussed in pre-stressor concrete, see students, the stress also varies in this way, and you can say compressive stress, and if you see the tensile stresses, it will be sigma st by m. Are you getting me? Where m is the modular ratio. What is m here? RCC is reinforced cement concrete. Mohammed Rashid, I didn't get your question mark. What is M means? Modular
You
ratio.
said na, this is the last topic. I meant, are we going to finish it today?
Yes,
RCC subject.
yes, yes. Why? Any doubt? What is M, sir? M is nothing but modular ratio, or you can write in working stress method. Modular ratio is equal to M is equal to 280 by 3 sigma CBC. This is the another formula. Sir, why you want to study about? Sir, we have retaining walls, water tanks. Oh, sir, retaining walls actually. Okay, Simran. Then I'll plan another talk day. Okay.
सर रिटेनिंग वॉल हो गया, टैंक डिजाइन,
Okay.
वाटर
And
टैंक डिजाइन.
also, I think then they will also ask you staircase also, I think.
यस सर, स्टेयरकेस भी है सर.
Okay. We'll plan one day. Okay. I'll plan one day. Okay. On Sunday or something. Okay. Don't worry about that. I'll plan one day. Don't worry about that. One day I'll complete. So here modular ratio is how much, sir? 280 by 3 sigma CBC. Next thing is, sir, see, actually, water tank design, or if you see any liquid tank, water tank design is followed using what, sir? Using working stress method only. Sir, actually, water tank design is method is working stress method only, because in working stress method, sir, why we follow working stress method in water tanks is no cracks are allowed. We've seen LSM method. Sir, in LSM method, no cracks are allowed. In working stress method, no cracks are allowed. Okay, that is one of the important thing I would like to tell you. Next, see, sir, if you see here, now here no cracks are allowed. You can say it is also uneconomical, means the cost will be very more in working stress method, because if you see the factor of safety for steel in working stress method, can anyone tell me what is the factor of safety for steel in working stress method? It is 1.78, and if you see the for the factor of safety for concrete, it is absolutely 3m. It is how much? It is absolutely 3. Now see, students, if you consider a section here, if you consider the stresses here, it will be equal to how much, sir? It will be equal to sigma CBC, and this will be equal to sigma ST by M. Now see, if you consider this the stress diagram, if I consider this as depth of neutral axis, that is KD, where K is a constant. See here. Now from similar triangles, you can write here you have a steel something, and this will be equal to D. So here you can write, student, sigma CBC upon AD is equal to sigma st by m into d minus kd. Okay, so here you can write sigma cbc upon sigma st by m, or you can write m sigma cbc by is equal to what, sir? K upon d will be cancelled, 1 minus k. Or if you write, if you solve this, can anyone tell me 1 minus k by k is equal to what, sir? Sigma st by m sigma cbc. So you can write here 1 by k minus 1 is equal to sigma st by m sigma cbc. 1 by k is equal to sigma st plus m sigma cbc upon m sigma cbc. So k is equal to m sigma cbc plus sigma st plus m sigma cbc. This is a constant. Are you getting me, sir? If you ask me about compression force is what? This is stress. Stress area of the triangle. The stress is sigma cbc into area of the triangle is half into d into k into d. This will be the compression force. Right or wrong? If you talk about the yes or no, students, this is stress, and where it is going to, sir, see, sigma cbc is the stress into area. This is the compression force. Now when you talk about the lever arm, where will the lever arm will act, sir? It acts at its centroid from d by 3. So d minus of kd upon 3. So this will be equal to d common d minus 1 by k by 3. This is equal to d upon 1 minus k by 3. So moment can be written as, here moment can be written as sigma cbc into half d into k into d square into 1 minus k by 3. That is compression force into lever arm. Are you following, students? Fine, sir. Sir, with this, we are done with the working stress. Actually, in working stress, I will teach you most of the water tank. Actually, water tank design is completely working stress. So I'll discuss more in detail in what water tanks and retaining walls. Next, please. सर वाटर टैंक डिजाइन में पूरा वर्किंग स्ट्रेस में बोल दिया, और रिटेनिंग वॉल्स और एक टॉपिक है सर स्टेयर केस, वो तीनों नेक्स्ट संडे में कंप्लीट कर दिया. ठीक है सर? एनी डाउट्स? ओके सर, इफ एनीवन वांट टू कांटेक्ट मी, you can contact me at my number 7386965320. Please WhatsApp me, Amma. I'll definitely reply you in WhatsApp. Fine, sir. Fine, students. So all the best, students. See, students, if you want to be success in competitive exam of state level AE, JE or anything, objective questions are very important. First read the notes and then objective. Sir, please try to prepare the previous year questions of IES prelims, okay, SSC JE prelims, and GATE objective questions only. Sir, if you required, you have to mug also. Means you can by heart also. Clear, students? I hope I have done justice. Sir, from next time onwards, if I am taking the class for you, if I know Hindi only, I'll be taking them. Don't worry, because I have a problem with my Hindi. So that is the reason. I hope you have enjoyed my sessions with me, and we'll see you in the next Sunday for the remaining topics. And I'm done, sir. So please try to prepare well for your the AE exam, and I hope these sessions will help you. Thank you.
So
लास्ट
can you
स्लाइड बताना।
please send the combined PDF of the whole lectures, complete lectures?
Okay. I'll try.
Will be
I'll
thankful.
try. Sure.
सर लास्ट स्लाइड बताना।
Sir, today what we have discussed the bond, and another thing is what sir I have discussed. Oh. Sir, please keep in mind all the previous IES questions, SSC JE prelims, GATE objective questions.
बैक स्लाइड करना है सर।
Okay, sir, all the best and all the best for your future. I hope that my sessions will help you. Thank you, one and all, and good night. Have a nice day. All the best to your future. Thank you, sir. Bye bye. And I'll see you on Sunday again for the remaining topics, and I'll complete, sir. Thank you and all the best. Bye bye.